For this video, we're going to talk about variability, the different types of variability, and how it's displayed in SPSS, and a little bit about how it is interpreted. So again, I'm using the same data set that I've used in the past, the demo.save. If you don't recall where to find it, you can look in your C drive under Program Files, IBM SPSS, Statistics 25, Samples, English, demo.save, or look at a previous video to see where I found this data set. So we're going to go into the variable view, and I want to identify some variables that are scale, or they're referred to as scale on SPSS, but these are what we call interval ratio variables. This is the scale of measurement. As I mentioned in an earlier video, how they're identified here is really up to the researcher. They're not always correct, so I'm going to take a minute and make sure that they are. So for example, marital status is unmarried and married. So it really is not a scale measure. It's actually a nominal measure. Years of current address, especially when it says none, it shows you that it is an interval ratio or scale measure. Household and income, price of primary vehicle, that looks correct. Retired is a no or yes, so it is in fact a nominal measure as well. And job satisfaction looks like it is a ordinal measure. And these are, all of these wireless, all of these are in fact nominal because they're yes, no. The reason why this is important to adjust is because when you're doing variability, you really can only do variability for interval ratio data. There is it is reasonable to do a range if it is ordinal data, but for the most part, the measures of variability, the standard deviation, interquartile range, and standard error are really just appropriate for interval ratio data, which as SPSS refers to as scale. So we're going to look at a few of these in terms of their variability. I do want to point out that under descriptive statistics, you do have two areas. There are frequencies and there are descriptives. The descriptives have the option to do standard deviation, which is an important measure of variability, and variance, but it doesn't do the interquartile range, and it doesn't do something else, which you'll see in a minute. So I'm not going to use this one. I'm actually going to go back and continue to use the frequencies measure, which I like because it allows me to do, I can get the mean, median, and mode. I can get the quartiles, which I'll explain in a moment. I'll do the minimum, maximum, standard error, standard deviation. So I've got quite a few pieces of information I can get for each of these variables. But I also want to, I'm going to click on charts and ask it to show me histograms with the normal curve. And you'll see why this will be helpful in trying to interpret the data. I'll say one other thing, that we're still a part of descriptive statistics, where we're still trying to just simplify and describe the data set that we have, while central tendency focused on just a single number that would help explain the whole sample. Variability gives us a sense of what the sample itself as a whole looks like. So we're going to look at, look at age, we'll look at years of current address, household income, price of primary car, level of education in years of current employer. Well, we might as well stick all of them. So we're going to put every single one of the interval ratio variables that we have in our data set and look at each of these. Again, we're looking at we'll get central tendency, but dispersion is the other word for variability. We'll also be getting that. So before we run this, we want to turn off the display frequency tables, because as scale measures, as interval ratio measures, we don't want to see those frequency tables. They'll just be pages and pages long, and they won't inform us in any way. And then we'll hit OK. And this is what we'll have. And we can talk about this now. And so here's a summary statistic table, descriptive statistics, that allows me to look at each of the different interval ratio variables that I just asked it to. And so what I find is I can look at age, and I have the mean, median, and mode. So the average age is about 42, with the median age of 41 and the mode of 39. So one of the things, while these are central tendencies, what it already informs me of is those numbers are very similar to each other. So I'm expecting that this is somewhat of a normal distribution, because when the mean, median, and mode are the same value, it means that it is a relatively normal distribution. Then I also have the standard deviation of 12.29, which means that essentially, on average, each of the values in the distribution are about 12 years. There's about a 12-year difference from each of the values from the mean age of 42. The standard error of the mean, if you've learned about this yet, basically allows us to get the general idea of what the population mean would be. So this is the sample mean is 42, and it tells us that the actual population mean is pretty much 42 as well. It's somewhere between 42.06 plus or minus the 0.15, which means that we expect the population mean to be pretty similar to what we're getting here. Again, we have the minimum age of 18 and the maximum of 77, which is also very useful, especially when we're looking at some of the other variables, such as years at current employer or household income, is to know that what our age group is. The percentiles is another measure of variability. It's interquartile range, and it basically uses the 50th percentile is also the same. It's the same thing as the median. As you can see, it's 41 for both. And so it basically says that the whole group, the whole distribution of the sample in terms of age, is split by the age of 41. The low and the high is also very informative, and this is similar to the cumulative percent, but it's saying that the bottom 25th percentile, the bottom quarter of the sample, is age 33 or lower. The top quarter, which is the 75th percentile, is 51 and higher. This also tells me, since 33, 41, and 51 are not that different from each other, that there is not a lot of variability. The same thing with the standard deviation. It's about 12 years. The interquartile range, it sort of suggests the same thing, that this is not a hugely variable sample. Next, I'll look at the years of current address. So I have the average number of years as being about 12 years, with a median number of 9 and a mode of 0, which I guess it was people who just moved there. So now I already know that the sample is somewhat more skewed, because for my mean and my median to be different, this different, and of 12 years versus 9. It's not a tremendously different amount, but for how many years you live in your house, it is at least worth paying attention to. Also, the standard deviation of 9.9. Now, this is really important, because when we're talking about age, in 6,400 people, having an average age difference from the mean of about 12 tells me that it's pretty close distribution. Then you look at years of current address, where the standard deviation is more like 10. Now you might think to yourself, well, 10 is smaller than 12, so maybe it has less variability. But the reality is is if you don't consider what the mean is, the standard deviation is meaningless. And so in fact, with the average number of years at an address of about 12, having a standard deviation of close to 10 means it's a very spread out group. This is further informed by the fact that we could see the minimum is 0 and the maximum is 56. So this is a widely spread out group. Again, we'll look at the households income in thousands. We talked about this before in earlier videos where the median and mean are considerably different. We see a standard deviation now of 78. That's $78,000 is the average difference from each value from the mean. So this is saying this is a very, very spread out, not normal distribution, given the fact that there's such a difference in the mean and the median and the mode. We can see again from the minimum and maximum, there's huge variability. Price of primary vehicle, we have an average price of, I'm assuming these are in the thousands also, of $30,000. And again, a standard deviation of 22 for a price of a car, $22,000 is a pretty big spread. So it's telling me this is pretty widely spread out. And we can see that in the minimum and maximum as well here. Level of education was a mistake. So here's a good example of how you can put in a variable and treat it like it's interval ratio, but it's really not. This was accidentally left as interval ratio, but it is obviously, I can tell from looking at it that it is really ordinal. There's not enough minimum and maximum. And this is very important. I understand level of education. You understand level of education, kindergarten through 12. Sometimes we call college 13, 14, 15, 16. We mark it by years. And then it could be an interval measure. But when we see 1 to 5, we know that this doesn't mean for first grade to fifth grade. So this informs me that this was a category and it wasn't interval. So we shouldn't even be having this in this example. And I could say that I did it on purpose to illustrate it, but I actually didn't. Next, we have years of current employer, where the average number of years is 10. The median is 8, so it's not a very equal distribution, especially with mode being 0. So I guess it's new hires. And the standard deviation is almost 9 years. So again, this tells us there's a very big variability between the different individuals in this sample and how many years they've been there. And this is further explained by that 0 to 57. That's a very wide spread where you have the lowest 25% being only 3 years or less, while the highest 75% is 16 years and more. But when you know that there's some as high as 57, we know that highest percentile includes some very, very long-term employees at a particular location. Last, we'll look at the number of people in the household. These are much tighter and smaller because it's just number of people live in the households. Again, on average, it seems there's about 2.35 people in the households, with 2 as the median. The mode is 1, so this is not a perfectly normal distribution because otherwise the 3 values would be the same, but it's relatively normal distribution. We do see it that it's skewed a bit by some individuals who have 9, which we talked about in the last video. I'd say the interquartile range is a little useless in this situation because the distribution of 1 to 9 makes the interquartile range seem a little less meaningful. So now let's see what this all looks like visually. So if you look at age of years, as mentioned before, we have a relatively normal distribution. The mean, median, and mode, if you remember, was relatively similar. The standard deviation didn't alert us to any kind of oddity of extremes. And you can see the shape of this is looking somewhat like a normal distribution, maybe slightly skewed down towards the younger age group, but it's relatively normal. If we look at years of current address, our mean is here at 12, right there. And then you could see that with that standard deviation that we've got a major skewed shape over to fewer years at the current address. But that there's some people who've been there a bit longer that impact that the distribution, but that it is mostly happening right around here. Similarly, a household income in thousands, we see that the mean is 70,000, which is right here. This is always the point of the mean, is the high point of the curve, and that this is extremely skewed down towards the lower end. There's just some very few people who are making a large amount of money. It's barely even showing on this particular chart. So we're looking at multiple measures of variability. We have the standard deviation. We have the minimum and maximum, which is essentially the range. Interquartile range, which uses the median. And then we also have standard error of the mean, which informs us about how much the sample mean represents the population mean.